everyone, I am here with Roland Memisevic. Roland is the co-founder and CEO of 20Billion Neurons. Roland, welcome back to the TWiML AI podcast.
Thanks, it's great to be back.
Absolutely. So we first spoke February of 2018, so quite a while ago. Our topic was learning common sense and physical concepts. And it sounds like 20Billion Neurons has made a bit of a pivot since then, and we'll dig into that. But before we do, it's been a while. Give us, those who may not remember that show, a quick overview of your background.
Yeah, happy to do that. So I've been in AI for some 20 years. I did my PhD at the University of Toronto with Jeff Hinton early on, 2003 and onward. More recently, I've been a faculty member at Mila in Montreal. And around 2015, 16, I embarked on this mission I'm on right now with 20Billion Neurons. Co-founded the company with the idea to build an AI system that is much more of the kind of AI system that is dear to me. That's kind of the type of AI that I'm interested in. Which is human-like AI, an AI system that I believe is going to take hold in homes and so on. Think about a C3PO type robot one day greeting you when you come home and providing value at home. I realized over the years that the way that I think about AI is a bit different than I sense how a lot of people think about AI.
How so?
When I think AI, I literally think about C3PO.
Okay.
I think about human-like robots that can understand you and be with you, and the companions essentially. And I came to the realization over the years that the AI boom that's happening right now has a lot of people associate something slightly different with the term AI than that human-like companion. It's more like superhuman pick and place in a factory. Or
automation.
Predicting hardcore automation in manufacturing setups, or predicting the best ad to show in response to somebody watching this video, and these kind of things, right? Algorithms running in the cloud, superhuman, very, very, let's say, directed towards industry applications and manufacturing and stuff like that.
Kind of narrow, single purpose in many instances.
I think it's part of what this type, or if you even want to make the classification of it, if you want to think of this as a kind of thinking of a kind of connotation, let's say, with the term AI, I would say yes, it's very, very specific. It's a tool, a very, very strong tool that solves a very, very narrow, highly specific purpose, like a hammer, to solve a very, very specific problem, rather than this bigger vision that a lot of us, I think, not just me, but a lot of us had in their head when they were saying AI in the past, which is, I don't know, I'm sorry, but I don't have a better metaphor than your C3PO, than your robotic companion that is there for you and understands you, and with whom you can have a natural engagement, in the sense that that system understands what you're talking about when you're talking to it, and has a shared mental model with humans, to the degree that we can build this kind of thing.
And what I remember of our prior conversation and what 20Billion Neurons was working on was that you were kind of starting from the idea of, I think it was kind of connecting it to this broader vision of AI from the perspective of like trying to build context and awareness. And you said that, as opposed to trying to identify objects in pictures, which is what a lot of people were doing, at that time, you were trying to identify actions in pictures and kind of more focus on the verbs than the nouns, so to speak. Maybe fill in the blanks for us.
Yeah, so if you look at where's the starting point for this, for your robotic companion that understands the world in a way that's similar to how humans understand the world. For me, it was evident, and that's what I've been focused on also for many years at the university. It starts with video. It basically starts with a system that takes a video stream coming in and then building a mental representation of what's going on there in front of the camera. So it has to be real time. In my mind, it has to be video. And then later it can be accompanied by audio and language and whatnot. But the seed for this kind of capability to me has been and still is real-time video processing. And I remember what we were talking about back then was going from nouns to verbs, if you want, specifically in the context of video, because in images there's much more bang for the buck that you get by recognizing stuff that's in the image. But once you talk about videos, and then you talk about a human-like understanding of the surrounding, the scenery, and so on, that should come up as a result of streaming this video in, then you're immediately landing at verbs and adjectives and adverbs, and basically a much more fine-grained characterization of what's going on than image goes in, label cat goes out.
Right.
It's much more
And
subtle
some
and
of the
varied.
examples that you use, if I remember correctly, were, if you have a picture of a hand holding a cup, and you're trying to understand, what's happening from a static picture, all you really know is that the hand is holding a cup, and your system could guess that the hand is putting the cup down or picking up the cup, but with a single frame, you have no idea. But then once you introduce this video element and you can learn from or observe from frame to frame, then you can actually start to label the verb, the action that's taking place. Um, and that is kind of the foundation upon which you're trying to get towards this C3PO.
That's right. It's basically the realization that video gives away so much more than images, that it's just inconceivable to try to build an AI system in the sense of AI as your C3PO by looking at an image and trying to build recognition systems that can distinguish this object from that object, and even this action from that action if it's a still screenshot of that action. You see so many things like occlusions. You can see that something's happening even though you only see half of what's going on because of occlusion. You get an idea about temporal information, especially when it's real time. The system has to learn to build a mental model that is giving justice to the physics and the scene that's unfolding in front of the camera, basically. And so early on, when we were doing this kind of experiments, we were making another bet here, right? So the really interesting thing is that we are ready. I deeply believe we're ready technically to embark on this more common sense infused understanding of the world and so on, in terms of the tooling that we need and the algorithms that we need and so on. I think we have what we need, and it's essentially we have a way to get labeled data, and we have backprop, and we have compute machinery that can train very fast on this kind of data. And I believe this is all we need to make a very, very big step into the direction of having representations that actually are informed about what's going on in the world and so on. And we took the first steps by building these data sets where you had to distinguish, I don't know, is somebody pouring something out of a receptacle, or is somebody pouring it into it, it's overflowing or not overflowing? Many different kind of distinction tasks where sometimes it's just a few pixels that give away what's going on in the scene. And we made a big bet that backprop is going to be good enough end to end, going from pixels to concepts in order to figure out all of these little details in the scene to make those prediction tasks work. And so it was also a very, very big bet on end-to-end learning. And
you also collected a pretty significant data set of labeled activities in video.
Yeah, so the bet being basically a bet on backprop, lots of data, and the compute machinery all being ready, naturally had to involve getting our hands on the data in order to have
Mhm.
that system do this stuff in real time. And so that was one of the early steps that we had to take in this organization, starting 2016, how to get our hands on the data. And we do this. We started to do it and are still doing it today using what we now call crowd acting. It's basically working with crowd workers so they interact with our systems in order to provide us with that data. And that's the opposite of what I would say 99% of data sourcing currently is in machine learning. We don't tag data that we get somewhere else, but we generate the data. It's generative data sourcing, if you want. We come up with the labels, bizarre things like I don't know, pouring this liquid onto your laptop or something, or looking at the camera while you're speaking to the device, or talking to somebody else while the device is on, and so on. And then once we have those labels, crowd workers give us the data, the videos, by interacting with the system and recording this video. And that way we generated many millions of videos of basically scenes, mostly indoors, not all, but mostly indoor scenes where people just do stuff and things happen to objects, and people engage with the device or engage with each other and do stuff, and things happen, things fall, somebody walks, somebody waves, lots of
Mhm.
gesture control initially, commercially. And with that database, we just have been training our neural net, if you want, our one neural net, if you like, over the years, piling up more and more data over time, discovering holes, realizing that it talks to you, uh, even though you were not addressing it right now. We're looking at it and stuff, trying to fix those problems, trying to do a little bit of lip sync and gaze and understanding more and more with more and more finesse all of the little distinctions that it has to learn and so on. And over time, this has grown into the system that's currently deployed, and that's basically able to understand thousands of things that could happen in front of the camera, all by streaming in pixels, and at this point, pixels and audio samples on the one side, and streaming out the behaviors that you want from the system on the other side, all trained with backprop and end-to-end learning.
And so this is, what I'm hearing thus far is kind of very much in line with, what we talked about again back in February 2018, TWiML Talk 111, for those who want to look it up. But I'm gathering that, something funny happened on the way to C3PO, and now the company has, quote unquote pivoted, and offers a fitness app. Is that correct?
That's right. There's a fitness app in the App Store. It's called Fitness Ally when you Google it.
Okay.
And it's a fitness app that when you open it, you're put in front of an avatar fitness coach that makes eye contact and then walks you through workouts that you can do with this fitness coach. And based on this technology, you guessed it, what this avatar then does is it sees how you're working out after building workouts for you, and it provides live feedback. It's very, very personal. It sees how you're doing, what you're doing, and so on. It counts your calories based on the camera input stream and all kinds of stuff. And that way is basically a workout companion for you. And the funny thing that happened in the meantime that had us embark on this app, on this consumer directed app, really, this is that it's doing streaming pixels in and concepts out is very, very ambitious computationally, not just on the training, but also on the inference side. And we still felt like it's good to make a bet that this kind of thing will happen at some point, even commercially, because it's just so valuable. It's having a personal companion. To me, it's like betting on, in the early 80s, some smart people were betting on personal computers, and everybody was calling bullshit on them and saying, no, nobody, it's not going to be that billions of people are going to be sitting in front of their some kind of terminal and typing and stuff like that. This is nonsense. And some people were betting against that and thought, no, personal computers are going to be a thing. And similarly, I feel strongly about making a bet on personal robots, if you want. Even if those robots in their initial, those C3POs, in their initial incarnation are on-screen embodied creatures and not necessarily a piece of metal with actuators and stuff. That giving us lots of leverage with backprop, right? So that's why I think this is how this is going to unfold in the first place. But then there is a lot of use cases where this is incredibly useful to have, and we decided that fitness is a beautiful use case because your personal trainer that's accessible, but share some of the relevant qualities with an actual personal trainer. We felt it's going to be incredibly useful, and having a conversation around how you're doing certain things, how you're improving over time, and how you can fix your form in certain ways and so on, and also killing boredom that way. Basically having somebody with you, that somebody around, the companion, so you're not working out alone, and then holding you accountable because it can count the calories based on the pixels that are streaming in and so on and so forth. We felt like this is a beautiful beachhead opportunity to get into. And so to go back to the funny thing that happened, it was in late 2018, Apple announced the latest generation of iPhones and iPads. And as it turns out, there is a chip in there that is capable enough to run a version of our neural net on device, battery powered, as these phones are, and privacy preserving. There is no streaming anywhere. And that's critical. That's important if you are visually working out with the device and so on. And we felt, let's give it a shot. Let's see if we can take this thing, port it over to a battery-powered tiny device that has hundreds of millions of devices in install base out there, and see what happens. Right. So that's essentially what happened.
So your model is running locally on these devices, and is the model primarily doing the inference of what the person who is exercising is doing at the moment, or is the model also doing, there are a ton of other kind of AI modalities in this vision that you've painted.
That's right.
Understanding how, the, speech or text of the person, generating responses to the person. Like how much of that, today is kind of this model and ML AI in general, versus, this ML core that's being used to identify what someone is doing, and then like heuristics or other approaches to supplement.
Yeah, so there is audio processing in there. So it does both. It does video and audio, but the audio is not going further than taking voice commands and basically skipping exercises and stuff like that.
Okay.
It was a very, very scaffolding kind of thing initially, where there's a lot of things that have to happen. The avatar has to be controlled, voice has to be processed, speech has to be output by the device, right? The avatar has to speak. There has to be an understanding of how you're working. What exercises are you doing right now? There are these blocks, these 30 seconds, etc. blocks where you do an engagement with this thing. There has to be a bit of dialogue. There has to be a bit of multi-hop kind of engagement, where if you stop doing your exercise and your trainer says, hey, what's going on? And then you restart it, it has to show the right kind of sequence of behavior and response. So there has to be a bit of multi-hop dialogue and so on and so forth. And the idea is that slowly over time, I believe this scaffolding is going to be eaten up by one big neural net in a few years. But for us, the name of the game is replacing a bit of neural net over here, replacing a bit of neural net over here, in order to move towards that vision where this is just one single audio visual engagement and it's just purely trained. And I see this similar to what happened around 2008 and onward with speech, right? There were these gigantic speech pipelines, and it was good that they were there. They were sort of the foot in the door. We had systems around that were around and actually used by people and so on that could recognize us to a certain degree what's going on. And then slowly neural nets came in and were eating up this whole stack, to the point where at this point there's lots of very far-reaching end-to-end speech systems out there. And I think the same thing will happen with your on-screen C3POs, with your on-screen companions over the next years. And that's where I think the community is going to be headed. The beauty of this is end-to-end and backprop can reach very, very far in this. So the point at which you hit reinforcement learning and other hacks and tricks that you need in order to advance things is still quite a bit out there.
How much of what you're doing with this fitness avatar is predicated on the model, the neural network that you built previously?
It's the same. So there
Yeah.
is. So the first things that we had to do in 2016 were, can we even train a 3D ConvNet? It wasn't even a 3D ConvNet. It was some kind of ConvNet with multiplicative interactions and whatnot, that where you stream in video and then it outputs what it's supposed to do in response to that. And it wasn't clear at all whether we even get this to work. And initially we made a bet again. It's a test case where we just have video clips that are labeled, like a few seconds of video. And then you train the system to take the clip as one big whole input, and then it processes it with its 3D convolutions, etc., and then outputs what's going on in the clip. And that output can be very varied. It can be complicated, many different classes. It can be combinatorial, and so on. And we were crossing our fingers and hoping that once we pre-train on enough clips, streaming it in and then rolling this net forward in time and so on is actually going to work, and it's going to enable the system to then be reactive in real time to what's going on in front of the camera and so on. And that turned out to be right. So lots of the data is still video clips, and when you run the system at inference time, it's basically just rolling forward and leveraging its internal representations to then determine whether you're stretching far enough, whether you're keeping straight, whether you're better than last time in doing this and that, and so on and so forth. It's the same network, right? So that network has now trained on a few million videos, mostly clips, and it has seen a lot of stuff. And it's easy for us to, for example, to add exercises because it's leveraging transfer learning big time, right? It's we don't need to start from scratch every time we want to teach the avatar to recognize another type of move or action that you do in front of it.
Mm-hmm. And so if we set aside, quote unquote, purely traditional approaches, a more traditional neural networky approach to this kind of problem might be doing like body segmentation of kind of body angles and that kind of thing, and kind of building up a pipeline from there. But you're able to kind of dispense with all that and just do kind of end to end, straight from pixels to what the person is doing based on that historical work that you did.
That's right. And you'd be shocked by how far this goes in terms of abandoning skeletons, pose estimates. There's a lot of libraries out there now where you have a video or even an image. Believe it or not, nowadays there's even libraries out there where mostly it's about an image in like this, and then a stick figure goes out that says some key points and so on. And you won't find any of that in this system. It just goes straight from pixels to saying, hey man, you gotta lift those knees a little higher or something. And so there is no bounding boxes, there is no skeletons, there is no segmentation of sorts, and temporal segmentation and this kind of stuff. It's just going straight pixels in, responses out. And it's working amazingly well. We did a whole bunch of tests on, how far could we have gone if we had used those pose estimation systems and stuff as a sanity check at the very least. And it's just incredible. It's not only don't you need any of that, but neural nets are very happy to just do this kind of tasks on their own if you feed them with the data. And
now, once again, you brought up kind of the key trade-off, right? If you had a pose estimator and you're able to, estimate your knee angles or your hip angle doing push-ups, you could kind of put some heuristic on that.
That's
and
right.
you'd
That's
be
right.
done. You, on the other hand, you need to go have a bunch of people or crowd workers watch a bunch of exercise videos and kind of rate the the push up knee uh, yeah, what did you even do? Did you kind of draw bounding boxes around knees and say
No,
um,
no, no.
how much
That's
of that
that's
did
the
you need to do?
that's right. That's right. That's the point. We don't want to ask the trainer to and tell it this is a knee and now look how it's moving and stuff like that. We want to tell the trainer, look, if you see something like this, say this. If you see something like that, say that. And everything is then implicit. It's so if you see let's use that exercise, high knees exercise where people are lifting their knees and stuff, and it
Mhm.
looks like this, then look, this is it's pretty good, but the form, like, I don't know, the pose could be, they could be like keeping their back a bit straighter, they should look forward, they should lift their knees a little higher, and they should go a little faster or something like that. And that's it, and so then the neural net comes along, it sees that video and just makes that inference and figures out that this is the issues that are worth calling out right now, for example.
Mhm.
And
Hey,
nowhere in that.
is that a novel approach? I think a lot of kind of data labeling is more well, I guess it's often akin to kind of identifying features, in
It
the
is.
your input image as opposed to kind of this very what I'm hearing here is like an outcome oriented labeling.
That's right. It's in the language community, it's direct to intent is a term
Mm,
that is used pretty often for that kind of stuff,
mhm.
right? And it's also in our audio stuff. It's also direct to intent. Don't don't train a system to predict intermediate stuff. We have failed so much with that, right, in the past. The speech taught us that initially. End-to-end learning is good. And it's actually, the harder the task, the better it is,
Yeah.
if you give it the data, right? So it starts
Mhm.
to generalize across concepts, and transfer learning starts to kick in, etc. And it's really interesting if you look across the history. It's like it started with in 2008 ish with speech, and then 2012 there was ImageNet, and then there were a lot of projects out there in early on when the ImageNet revolution, if you want, happened, where people went, okay, cool, end-to-end learning works well. Let's try to predict SIFT features, or let's train a neural net to predict like this intermediate representation and that intermediate representation, and then this thing marched on to machine translation. And then there was a lot of talk about, let's go, instead of going end to end, let's go and predict the pass tree and then this aspect of the language and that aspect and so on. And in all of these cases, the further you went end to end to what you actually wanted the system to do, the better it worked, ironically. And thus basically we have taken this insight and moved it to real-time video and companion, kind of training a companion to do the right thing in response to what the perception channel tells you. It's
Mhm.
sort of that's what it is, right? It's like, how far can we possibly push end to end, bypassing pipeline, for this kind of thing. And it's surprising how far this has pushed us at this point, in my opinion, because it's surprising how homogeneous the system now is, and that's actually what leverages the iPhones and iPads. And now we have an Android version, and it's going to launch later this year. The hardware ecosystem is configuring itself to serve these kind of compute needs, right? Like very, very homogeneous, very simple matrix multiplication. Same things
Mhm.
happen at many different places and so on, which is it's a different compute paradigm that's behind AI. That is, I think, a big reason why this works so well and so on. And being able to exploit that, because you just have a very homogeneous neural net that is just a neural net. It doesn't need
Mhm.
to keep this around and have that module and talk to each other and stuff. No, it's like, give it parallel hardware, it's going to stream the stuff through that parallel hardware, and it's done. And I don't know, I just can't see the hardware ecosystem evolve back to weird hybrids and stuff. I just think it's real now. It's massively parallel hardware and so on. It's just going to stick around, and it's going to grow. And
So
uh,
kind of launching off this topic of it's just a neural net. Your early work was based on, well, you mentioned kind of 3D CNN architectures. In some of what you're describing, I could see a role for some of these large language model types of approaches.
Mhm.
Is there, do you use any of that stuff? Is there kind of a hybrid approach that is interesting, or are you doing kind of just end to end CNNs and making everything work from there?
Yeah, I think there's a gigantic opportunity for the whole community merging language and video processing into one thing,
Hmm.
because that's how grounding happens and all of that stuff, right? And that's
Hmm.
the long-term bet anyway that we have with this, and that many people have, is like why they are doing audio-visual stuff in the first place.
Hmm.
And I think it's a huge opportunity. It's going to take a while, right? So right now we're in a phase where we're putting together this scaffolding kind of thing that I mentioned, where the neural nets has to eat up pieces, piece by piece, and so on. And on the word embeddings and language side, I think these GPT-3 and whatnot are a beautiful ingredient there. Um, and I think it makes perfect sense to mix these kind of things together, because what you could argue that what big language models are missing is that wire to the real world that grounds those
Yeah.
representations. If I walk up to this avatar and they say, "Hey, Ali, what am I holding in my hands right now?" And the avatar has to respond, you're holding in your hand a phone and a glass of water, whatnot.
Hmm.
And then I walk up to the avatar and say, "Hey, Ali, what did I just do?" And the avatar has to say, "You jumped and you clapped in your hands." The word embedding for something totally unassuming, the word "and," say, in these sentences,
Hmm.
the word embedding for "and" has to start to encode things like spatial juxtaposition, which is sort of an aspect of the word "and," of the meaning of the word "and," right? That's how you
Hmm.
learn as a child what "and" means. It has to start to conceptualize events like jumping and whatever you do. Similarly, it has to sort of use a similar representation as for objects, for events, and it has to start to reason in a way that's very, very different from how a purely text-based system reasons, if you want, about what's going on. And so I would argue this is probably the biggest opportunity for the whole community to get into audio visual dialogue, like head on, that way. And what's curious though is Backprop is a motor for this currently, and I think it's going to push us way further than we currently have gone. In order along this trajectory towards reasoning and these kind of things.
Hmm. Hmm. Well, there are, I can imagine a ton of folks that I can put up in a debate with you on, both that statement as well as, end to end versus kind of model based approaches. There are a couple of, strongly held opinions there that are not universal, but it's super cool
Indeed.
to hear how you're applying them, which is, what's interesting. What's the name of the fitness app?
It's called Fitness Ally,
Fitness
and
Ally,
yes, ALLY, and it's available in the App Store and in a few weeks
soon
on Android.
Android.
That's right.
Awesome. Awesome. Any other updates that make sense to quickly cover?
One thing that's worth mentioning is we have an SDK now
Nice.
that's available for download on our website, 20bn.com, 20bn.com.
And so you're still kind of in parallel pushing for this kind of platform framework,
Yes.
enabling tech vision while kind of using the use case to mature that.
Yeah, you can use the backprop analogy even there. If you have an
Huh.
end-to-end reason for the system to behave in a certain way, there's no better learning signal than that. And,
Yeah.
and a utilitarian application that is just providing value, like making you fit and so on and healthy. It's a beautiful learning signal to see which kind of aspects of the world do you need to understand, and when does it get really personal, and these kind of things. And
Mhm.
so we're sort of using Backprop also, and that app where that has to survive in face of consumers playing with it and wanting value from it and so on. It's a great way to inform the neural net in the end, right? The neural net and the data operation and everything about what's next, what features is it lacking, and so on and so forth. So Backprop all over the place.
Also, I love that application of that analogy. Well, Roland, it's so great to catch up with you. Wish you the kind of best of continued luck, and let's stay in touch.
It's been a pleasure yet again.
Absolutely.
Thanks.
Thanks, Roland.